Hey guys, how are you going? I hope you're well. It's our second week. I'll start cubic function. It's gonna be only 9 sections here. Yep. So I will cover 1, 2, 3 this week. Okay. It's gonna be much lighter than last week. So I'll just go back to normal speed. Yeah. It won't take too long, and the concept itself is not too complex either. So hopefully you can follow it slowly and you can catch up from last week as well. Now you can start assignment 5 now. Yep, you go to, I'll probably email you today, link assessment 5 section, so you can go and check it. If you don't have printer at home, you can just copy that assessment in your exercise book and complete that and send back to me. That should be fine. Sounds okay? Yeah. So that's due 1 week. I'll give you 1 week. The assessment 5 is linked with quadratic function. Okay. And a couple of students asked me some questions. I'll see if I can give you feedback. I will do it through this week. Otherwise, I'm just probably check with assessment 4 and 5 videos. Just go through it together. Yeah, because if you send me a bit earlier, I can do it. But I'm already start cubic, so I'm not sure I can give you that feedback. We'll see how we go. Otherwise, just email me. I can give you a call and explain it. All right. Okay, let's start cubic function. Cubic. Before we start, let's go to section 1. Let's learn language of polynomials bit. Okay, let's just check one by one. Here we go. Expressions of higher order are sometimes called polynomials. It's like function. It is function, but we call another name is polynomials here. Okay, polynomials. There's an expression because you can just write down 2x power 4 plus 5x cubed minus 4x squared plus 2x minus 7. If I write down that without equal sign, that's the expression, isn't it? Expression and another expression, and we equals it, that will make polynomials. Okay? Or in this case, if you see F sign here, that stands for function. Yep. It's just output result. Okay, I can write down fx, or if I specify this is polynomials, I can write down px. Doesn't make any difference. It's the same thing. So when they specify some polynomials, I'll probably use p, but otherwise usually I use fx. So the function depends on x. The polynomials depends on x, which is input. You can see here. Or that's also same as y equals 2x power 4 plus 5 squared plus 2x minus 1, the same thing. So I can write down either fx, px, or y, they're all the same. Fx depends on the situation. Means all output. Okay? Y depends on what? X. X. That's how you express it. Okay? I can write down later on g x. The function g depends on x. So I don't know what it is, but it will be written as x form, which is going to be polynomial as well. But probably all you need to know, they are the same thing, which all just talk about output. That's it. Okay, leading term of a polynomial is the term of highest index. Index means power. With a non-zero coefficient, which means coefficient, number in front of letter, yeah, is not 0. Because if that's 0, it will make whole thing 0, isn't it? So Either it's nothing there, which means 1, isn't it? Otherwise 2, 3, we have coefficient. So we call this as a leading term. Highest power you can see. So in this case, I can see highest power here is this, isn't it? That's the leading term. Highest power squared, x squared is the leading term, 3x cubed is the leading term, x power 4 is the leading term. So you understand what's leading term? So you must know what is leading term. You need to know the terminology. Yeah. And then degree of a polynomial, which is function, okay? Degree of function, same thing, degree of function. For this, you go leading term and check power index of the leading term, which is 1, isn't it? So degree is 1. In this case, the highest power, x squared, degree is 2. So next one is degree is 3, degree is 4. The highest degree will make the 1 linear, 2 quadratic, 3 cubic, 4 quartic. Simple enough for you guys? Yeah. So please make sure you know what is leading term. Write it down in your exercise book. And degree of a polynomial. The value of polynomials can be determined by substituting a value in the polynomial x. Yep. Which means value of polynomials is y value, or p x value, f x value, which means outcome or output. Yep. Output can be determined. Yep. These values based on what? X value. Yeah, depends on what we put in x. For example, x minus 5. So in this case, we keep using polynomial. So I will use p. Px equals, I'm just using this, x minus 5. So that output depends on what is x, isn't it? So I'll just put anything. When x equals 0, px, which is y equals what? Minus 5. When x equals 1, px, when equals 1, I can write down 0 here, equals minus 4. So now I can write down p. When x equals 2, I'll write down 2. Y is 2 minus 5, minus 3. When x equals 3, minus 2. Does it make sense? Yep. So you write down that x value here. That's why they look like this. X value equals whatever you get, gonna be output y value or px value or fx value. Same thing. Do you understand? Okay, I will continue. It's quite, easy start. Should be fine. If fx equals 2x cubed plus x squared minus 3x minus 4, determine when p 1 means when what is 1? X is 1, isn't it? All I need to do, plug in 1 into the equation. P is 1 equals 2 x cubed, so 1 cubed, I write down this time, plus 1 squared minus 3, 1 minus 4. 1, 1, 1, 1, 2 plus 1 minus 3 minus 4 equals minus 4. Sounds good? So that's all you need to do. Now I write down P1 equals minus. Okay, can you do when P is minus 2? Well, X is minus 2. What do we get as our output P? Can you do that first? Okay, Pause it and do it first. Okay, that was easy, wasn't it? So go back, and you should get minus 10. Minus 10. And it should be fine. Alright, I will continue that. All you need to do, just substitute whatever number in the bracket, which means that is x value. You want to know when x is that value, what we're gonna have as an output. Yeah. Next one. When we don't know what is x, but whenever we put x, that's what we're gonna get as an output. Yeah. Question 1, when x is 3, I'll do that. Sorry. 3 equals 3 cubed minus 5, 3 squared plus 3 plus 1. You can do it at once anyway. So 27 minus 5, 3, 3, 9, 45 plus 3 plus 1 minus 14. I just did it, so I just copy that. You can do that. I don't have spare one, so I had to use it. Yep. Next one. Maybe use it from here. Do I have spare thing? Oh, here. Next one. Px plus 1. Alright, on this. So now we have x plus 1 instead of x. What is that? Look at this. P, when x is x, we have x cubed minus 5x squared plus x plus 1, isn't it? Yeah. Now we want to know when P is x plus 1 instead of x. So all I need to do, I put x plus 1 instead of x. So x plus 1 instead of x cubed minus 5, x plus 1 instead of squared, x plus 1 and plus 1. Can you expand it? I'll let you do that. Okay, can you expand it? Cube. Pause it and do it first. Oh, wait, I make mistake. X is not correct. 2x, 3x. Oh, yes. Make sure. Continue the minus. That one, minus 5 times 2x, so minus 10x. So it should be minus 6x. Don't make mistake for that. You guys all good? Yeah. We'll probably talk about this tomorrow. Yeah, next lesson, so you can memorize it. Maybe good to memorize the formula, but we'll just continue that one. Okay. Example 2. Example 2. If polynomial depends on x equals 3x cubed minus 2x squared plus ax plus 6, when x is 2, when we do the whole thing plugged in, we should get 12. Okay, we should get 12. So our result, output has to be 12 when we put x is 2. So let's do that here. When x is 2, so I'll write down 3x cubed minus 2x squared plus ax plus 6. 3, 2, 2, 2, 8, minus 2, 4, plus 2a plus 6. Which is, what should I get? I get 12, isn't it? 12. Continue 12. You don't have to write down. You can write down at the end. I'll just write it down. 24 minus 8 plus 2a plus 6. 12 equals, I'll write down here. What do we get? 16. 16 plus 6. 22 plus 2a. 2a, move there, minus 10. A divided by 2 divided by 2, minus 5. Therefore, a equals negative 5. Okay? So, negative 5, correct? Does it make sense? Yep. I mean, obviously, one unknown one, we know everything, one equation, we can solve it. Yeah. So we continue that idea. It's not too hard. It's all algebra. Example 3. If px, polynomial x, so we got the function here, power 4 minus ax cubed minus 2x squared plus bx plus 2. And how many unknowns here? 1, 2, isn't it? So we should know two functions here. So 2 x's. Then we can get it. Oh yeah, we have 2 here. Okay, 2 there. When p is 2, so when you plug in 2, we should get minus 8. Good. And when p is minus 1, minus 1, minus 1, minus 1, minus 1, when you plug in, we should get 4. And then we need to get a and b. We will have two functions and two unknown. We can get it. Yeah? Well, I'll let you do this question first. Can you try that question? Yep. And pause it. Try the question first, and we'll come back. Okay. How was it? Wasn't too bad, wasn't it? Yeah. So I'll just go through this one. We've already done it. Y, the whole value, when we put 2 into x, we should get minus 8. Just continue. I'll get minus 18 equals minus 8 plus 2b. All I need to do, put x is 2, and that result is minus 8. Okay, instead of px. This one, when x is minus 1, plugged in minus 1 into that original equation, our result is, which is px, we got 4. 4. So simplify it, I get 3 equals a minus b. So I have minus 8 plus 2b equals minus 18. A minus b equals 3. We've done it before from linear. Yeah. What do I need to do? You can substitute. Yeah, you can substitute, which makes a equals 3 plus b, isn't it? A equals 3 plus b. Then I can put 3 plus b into a minus 8. 3 plus b plus 2b equals minus 18. I can expand it. 6b equals 6, b equals minus 1. Okay, and you got b. What do you need to do? I need to plug back into that equation. When b is minus 1, minus minus plus, so 2 plus a plus 2 equals, oh no, 1 equals 3, a equals 2. Sorry, I knew a equals 2, so a equals 2. Okay, that's one way you can do from linear, yeah, substitution. Or here, previously I used what? I did times 2 here to eliminate b. Either way, you will get the same answer. You need to be able to do both. Okay? Make sure you go through this. Otherwise, go back to linear and check it. Okay, next. Polynomials can be added and subtracted by, yep, it's the same thing. Function px is this, qx is that. And then the question asks you, px plus qx, all you need to do, you add both px plus qx, like term, power, you check the power, x5, can you find it? No, so I write down 4x power 5, and then next, power 4, 3 plus 7, 10, 10x, square, I can't find cube, only square there, 3 minus 3, 0, 0 times x squared equals 0, it's gone. Next, minus 6 plus 7, 1x, which is x, plus 7 minus 9 minus 2, so I get that. Okay, all you need to do, collect like terms. Okay, next one. Two px minus qx. 2px is 2 times px minus qx, isn't it? Twice bigger than px. All I need to do, times 2. So what is px here? 3x power 4 plus 3x squared minus 6x plus 7, isn't it? Yep. All I need to do, times 2. Times 2, 3x power 4 minus qx. Oh, that's all I need to do here. Yep. So expand it, 6x, 6, 12, 14. And make sure it is negative, expand it. So change all signs. And then you go and take the like term. Oh, here. Power 5. Done. Power 4. 6 minus 7 minus 1 minus x. Yeah. And plus 6 plus 3 plus 9. Minus 12 minus 7 minus 19x. 14, 9 plus 23. Am I right? Correct, except I lose 7. Oh, what did I do? Why did I do that way? Okay, I'm correct. Okay, I'm correct. Because the minus x power 4, 7x. So that will give you 6. What's wrong with that? Okay, well, let's double check. 6. Is that right or wrong? 6 minus 12 plus 14 minus 5 minus 7x 2x squared minus 7. Oh, good. So just 6 minus 12. This is downside. I can't communicate with you. Well, if you see any wrong, you can just do it. So maybe either this or that is wrong. Okay, I'll double check. Minus 4 power 4. This looks alright. Yeah. Well, at the moment I can see. But please let me know if it's wrong. But all you need to do, if anything in front of P or Q, you can do that. It's like a normal algebra, you know. C. Px, when x is 2, all you need to do, plug in 2 into x. We've done that. So you can try that one. You do it, yeah, and then double check. Next one. Px plus qx is this. When x is 2, all you need to do, you plug in 2 and 2 here. So you plug in 2, 2, 2, 2, 2, 2, 2, and you calculate that, and you will have that. All you need to do is plug in the number. So that's not really a big deal. Yeah, they can say when x equals something, then you plug in. You already have equation. All you need to do, substitute. Can you make sure you do it by yourself first? Next one. If px is this, qx is that, you add it. Yep, you add it. So you go 4, 5. Okay, I can't find any other power index 5, so I'll write down px plus qx equals 4x power 5. Can I see 4? It's 4 here. 5, 3, 8. Yeah. 3 minus 2, 1 plus x squared minus 6, 5. You just compare the same thing like that. Minus 6 plus 1 minus x minus 7. Good. So you just collect like terms. Next question. Any number in front of p, which means 2 times all the p. So that will make 2 times 5, 10. 2 times 3, 6. 2 times minus 2, minus 12. 2 times 1, 2. That's what you're going to get. And minus bracket, the whole qx. 4x. And I solve it. Minus. Please remember that. You must do that. Minus 4x5. Change the sign. Okay. And then like term. Done. Power 4. Any more? No. 10 minus 3. 7 power 4. There's no cube. Square. 8. X minus 17x. Number 10. That should be the answer. Good. Okay. It's just whole algebra so far. Two polynomials are equal when it is algebra. A equals B, two polynomials, or Px equals Qx. In this case, probably more look like that, yeah? Corresponding coefficients are equal. What does that mean? If Px equals ax squared plus bx plus c, and then Qx is 2x squared plus 3x plus 1, when I say Px equals Qx, ax squared plus bx plus c equals 2x squared plus 3x plus 1, isn't it? I mean, it's logic. Therefore, a is what? 2. A equals 2, b is 3, c is 1. The corresponding coefficient are equal. Sounds good? Yep, well, you use it a lot though, yeah? It makes sense. Consider two polynomials, px and qx. Therefore, they are the same, they are the same, they are the same, they are the same, isn't it? Because they are corresponding coefficient. Good? Okay. Then px equals qx if and only, I done it just now. For example, px is this, qx is that, therefore px equals qx, so 4 equals 5. I just did very similar question, so you can just check it. Do that again. Question 5. Okay, then question 5. I'll just do that. The polynomial px equals this can be written in form like that, where b, c, r, we don't know what is b and c and r, a real number. It's just condition. We're dealing in real number anyway, yep, but just give you extra information. Find the value of b, c, r. Okay, I'll rewrite this. Px equals x cubed plus 3x squared plus 2x plus 1 can be written in the form of, which means equal to x minus 2x. They are the same, isn't it? Yep. I know what it is left hand side, but I don't know what is b, c, and r. So they said left hand side is same as right hand side. So as long as I can expand it and simplify it, I can compare left hand side and right hand side. So usually this question, you just expand it and simplify it. I'll do one by one, x times, so x cubed bx squared plus cx. And then minus 2 minus 2x squared minus 2bx minus 2c plus r. And that equals this one, isn't it? Yeah. In this case, can you see left hand side? Yep. Right hand side? Any cube here? No. So, are they the same? Yes, they should be the same, isn't it? It's correct. And next one, 3x squared equals any x squared? Yep, this and that. So, b minus 2 x squared equals 3, isn't it? So, b minus 2 is 3. b equals 5. Good. Done it. Next, x and x. So 2 equals, I'm dealing with the x, 2 equals minus 2, oh no, sorry, c minus 2b. Yeah, c minus 2b. c minus 2b equals 2. Well, there are two unknowns. However, I know b is 5 already. I can just plug in 2 equals c minus 5. c equals 12. So I know b and c. In the last one, number 1 left equals minus 2c plus r. c is 12, 1 minus 24 plus r equals 25. Correct? Yeah. So I get c, b, r. You're just comparing left hand side and right hand side. Yep. Doing simple algebra. If you need to expand it, you need to expand first. Collect the like term. Yeah. Make sure going through these, so you're able to use your calculator. Yep. I'll just skip that. It's explained pretty well here, and then you're able to use it when you double check your answer. Okay. When the last part, getting there. Yeah. Example 6. Well, we already done around 40 minutes, isn't it? Yep. If you want, you can have a quick break, pause it, yeah, and drink some coffee or tea or water. Exercise, and then we can start. Okay. Example 6. Okay, well, it's basically they ask you to expanding it, isn't it? You got 3 factors here. Doesn't matter which order. It's times, so you can just do it. In this case, I did this first. X squared 2x, and then bracket 3 x plus 3, and then all I did was expand one by one as well. 1 x squared plus x cubed, x squared plus 3x squared, expand. And then after expansion, all you need to do, like terms. Only one, write it down. 3, 2, 5, 6. So I get, that's all you need to do. Doesn't matter how big. Another thing, you can see x something, x something, x something. How many x's do we times it? 1, 2, 3 x's there. Yeah. So when we do that, I know we will have cubic. The answer should be squared 1, isn't it? If we have 1, 2, 3, 4, I will have power 4 something, isn't it? Correct. That's something you can guessing as well. When we do that, what I did here, let's be cold here. Expand, x squared, 5 minus 1, 4x, minus 1 times 5, and then x plus 2, expand one by one, and then like terms. Please do that individually. I don't think I really need to do that for you, but you can compare your answer and my answer. Okay? You need to be able to do that. make sure you can do it fluently. The last one here, you must know. That will help you a lot. Okay? Help you a lot. I'll probably show you. It's cubic. So all a plus b cube equals a cube, b cube. And then all I need to do, 3a square b. Okay, so the next one, 3a, but this time b squared. That's how I remember it. A minus b cube, a cube, b cube, and then same thing, 3a square b, 3a b squared. So keep one by one, and then we did it previously, Pascal's triangle, plus minus, plus minus. So when you have negative in front of b. That makes sense? Yep, you can use that directly. So in this case, can you do x plus 2 cube first? Can you do that, please? And then, like this, you can do x minus 2 cube. Okay, I'll let you do that first. This one and that one. Pause it and do it. Okay, let's do it together. Compare with yours, okay? You do it first. I'm waiting. You do it first. Okay. So in this case, this is A, isn't it? X is A. Number 2 is B. So x cubed. Good. And then 3 times, I'll just do twice, okay? I want to show you. X squared 2. Good. I'm just following this. Plus 3, and this time I'll use left hand side only once and right hand side twice. X 2 times 2, 4. And then 2 times 2 times 2, 8. So A is x, B is 2. You can think this way, yeah. X cubed plus 6x squared plus x plus 8. You can do that straight away. That make sense? And also same thing, they did it here. All I need to do, think about it. Don't worry about plus and minus here. A and B is x and 2. Same thing as well. X cubed. In this case, next one I usually get used to. So now I write down 2 first. 2x squared. Good. And next one is going to be x. So 1 less. Always go that way. And I use only once or twice. Twice. 2 times 2, 4. Good. And then I forget something here. What? Times 3. Good job. Times 3 times 3. So I can do it once. And then 2, 2, 2, 8. Good. However, we have what? Negative. Therefore, this has to be negative. Plus, minus, plus, minus. The answer is good. You will get used to. So, can you try x plus 3 cubed? X minus 3 cubed. Try that. You need to get used to. and answer is use that using calculator. Use calculator. You must know how to use calculator. Yep, and you can get that. Sounds good. So do it first, and then check the answers using calculator. All right. I'll wrap it up. This lesson. Well done, guys. This will give you quite a lot of ideas. Please continue. Questions here? Yeah, questions there. So it's normal lesson. It won't take too long. However, this week you have to spend some extra time to do assessment 5. Okay, assessment 5. I will give you 1 week. So you can complete by next Tuesday. I think that's what I wrote down, isn't it? Yeah, next Tuesday. Same way you upload it. And at the end of this week, I'll probably upload the solution video for assessment 4. Okay, all I'm checking is you done or not. But what you need to do when I upload the videos, you go and check your solutions. Okay, that will help you. If you have any question, email me. Yep, I know it's not going to be the same as I'm teaching in front of you guys, but hopefully I'll give you enough feedback. Okay, if you ask me for you do it early and ask me early enough, then I can respond most of your questions. But like weekends, probably a bit difficult to answer that. Okay. Thanks, guys. Have enjoy your first class and make sure you study. All right. See ya.